Welcome to chemistry. We are going to look at topic number 1. Although we have done some other topics, we want to talk about kinetic particle theory. This is a very important theory for you to understand chemistry. By the end of this lesson, you should be able to describe a solid, liquid, gaseous states of matter and explain their interconversions in terms of kinetic particle theory and the energy changes involved. Describe and explain the evidence for movement of particles in liquids and gases. You have to provide evidence. Explain everyday effects of diffusion in terms of particles. What is the effect of diffusion in our daily lives? Then state suitability, state qualitatively the effect of molecular mass on the rate of diffusion, and explain the dependence of rate of diffusion on the temperature. So let us look at first the kinetic theory. This is a theory, it's a set of ideas that are internationally accepted, agreed upon that it's true. So that is a theory. So when we talk about kinetic particle theory, we are talking about the ideas explaining the particles of matter. Okay, so the theory states that all matter is made up of particles which are in constant random motion. So when they ask you to state the kinetic particle theory or kinetic theory of matter, you are supposed to say kinetic theory of matter states that all matter is made up of particles which are in constant random motion. So this accounts for the properties of the three states of matter and the changes. So all the changes in terms of matter, they are dependent on a kinetic particle theory or kinetic theory of matter, which states that all matter is made up of particles which are in constant random motion. So the second objective, properties of the three states of matter. So when we talk about properties of something, we are talking about the characteristics or what makes them to be unique. So here we have a table, property. Sometimes they bring this table. I remember if it's 2020 or 2021, they brought this table. They left some blank spaces the way it is. So people failed because they don't pay particular attention, they don't study. So here under property, the first property is structure. The next thing is packing of particles, which you can call arrangement of particles. The next thing is movement of particles, shape and volume. So you have to explain all these properties in terms of a solid, what happens when it's a solid, liquid and gas. So in terms of structure, how do you identify that this structure is a solid, this one is a liquid, this is a gas? So for a solid, the particles, they are orderly arranged, okay? More like they are being arranged in rectangles. So they are properly arranged and there are other spaces between them. So they are tightly packed. So as you can see, so when you are told in an exam to draw the diagram showing a solid, this is how you draw. Okay, you have to ensure that all the particles, they are of the same size and they are well arranged. Then in a liquid, you find that there are spaces and they are zigzag in arrangement. They are not in orderly manner. Okay, they are not arranged compared to this one. So, and there are more spaces compared to the solid, which is fixed, packed. Then for gases, it's random and there are very large spaces in between. So this is how you draw. Then packing of particles. How describe the arrangement of particles in a solid, liquid and gas. Arrangement of particles in a solid, tightly packed, arranged in an orderly manner. So you have to be very careful with the property. If you ask to state the arrangement of particles, don't talk about movement, can vibrate at their fixed position. That's not what you have been asked. Pay particular attention to what is being asked. So if they say describe the arrangement or explain the arrangement of particles in a solid, you say particles in a solid, they are tightly packed, arranged in an orderly manner. While in a liquid, packed closely together, but not as tightly as in solid. This is just English, no regular arrangement. Then here you say spaced far apart from each other, as simple as that. Then movement, when they tell you to describe the movement, sometimes they can use the word motion. It's the same thing. Movement or motion can only vibrate at fixed position. So particles in a solid can only vibrate at fixed positions. Then particles in a liquid slide past one another. They slide on one another. Okay. Then particles in a gas move freely at high speed. So what is differentiating gases in terms of motion from these two is the velocity, high speed. These particles, they are not only moving freely, but they move at high velocities, high speed. Then shape, here it has a fixed shape. It looks like a rectangle here. It can be drawn in form of a rectangle, a square, a trapezium, as long as the particles are arranged in order, tightly packed, and in an orderly manner. Then here we have no fixed shape. Takes the shape of the container it is in. So for example, water. When you pour water in a balloon, it will look like a balloon. When you pour water in a plate, in a dish, in a basin, it will look like that, the shape. It will take the shape of the container. Then no fixed shape takes the shape of the container in it. So the only similarity between liquid and gases in terms of shape, they both have no fixed shape, and they take the shape of the container they are placed in. Then volume. In terms of volume, solid has fixed volume, not easily compressed. You cannot compress it, more like a foam, a mattress can be compressed. A bicycle tube which has been inflated can be compressed, but with a solid stone you can't compress it in your hand. Then liquid, fixed volume, not easily compressed as well. Then gases, no fixed volume and easily compressed. This is the reason why gases are used to inflate car tires or bicycles, tubes, balls, balloons, because it can easily be compressed in one place. So that is what it is. So changes of state. So when we talk about change of state, we are talking about transforming from a solid to liquid, gas, and vice versa. Okay, so here I've got a diagram here. We have this is a solid. So if a solid changes to a liquid, we follow this arrow above, outside. This is melting. The process, melting. So name the process is melting. What change of state has taken place? This one has changed from solid to liquid. So the process is melting. Then liquid to solid, that is freezing. You put water in a fridge, it freezes, changes from liquid to solid, that is freezing. Then here we have what? Solid to gas. Okay, solid to gas, we have what? Sublimation. It has not passed through the liquid part. So sublimation is the direct change of a solid to gas and vice versa without passing through a liquid phase. Then liquid to gas to liquid, that is condensation, which happens with the rainfall. Okay, vaporizes from the land and the oceans and condenses below the clouds there and comes as rain. So we have liquid to gas. When you are boiling water, you want to cook nshima, you are boiling water. So that is boiling or evaporation, because the liquid will change to gas. Okay, you see on your lid, below the lid and above, if there are spaces, vapor will be rising. So this is the end of this topic for today. So in the next lesson, I'll be talking about the cooling curve and the freezing curve. Thank you so much for your attention.